Hello everybody. In this video we will discuss some of the multi-step synthesis strategy where we're going to convert our alcohol to another type of alcohol but with more carbon atom. So you notice this is a cyclohexanol, so we have 6 carbon atom in total, but in this case this is also a cyclohexanol derivative, but we have 2 extra carbon atoms. So this is 6 plus 2 carbon atoms, so you have 8 carbon atoms. Okay, so I might let me color code this so that you can see the difference between these two. Okay, so you notice this was a secondary alcohol to begin with. Okay, and this one is a tertiary alcohol plus 2 extra carbon atom. Okay, so when you have a situations like this and the 2 extra carbon atoms are connected to the carbon atom which is connected to OH, more often than not, what you have to do is you have to use Grignard reagent. So like this is a rough approximation. So every time you see an increase in number of carbon atom from your starting material, we more often than not, we're going to be using Grignard reagent. So based on our knowledge, how can we make this? Let's try to synthesize a strategy. Okay. This is another problem on the bottom here. This is another problem. Maybe I should move this problem a little bit away for now. Okay, so how can we make this? Okay, so we can make this if we somehow make an aldehyde. Okay, so if we have an aldehyde like this and we treat them with CH3, CH2, CH3, CH2, MgBr, if we treat them, so we know that this would react as if this is CH3, CH2 minus, and this would come attack here and push the O negative ion here. And then in the next step, okay, so I'm drawing the mechanism here so that you can see what exactly is happening. So this would come attack here and this would go here. So you will end up making O minus, and the 2 carbon atom got attached to it, right? CH2, CH3. Maybe I should show this CH2, CH3. All right, so that's we just added. Now all we have to do is add a proton source to neutralize it. So that would be our second ingredient. So our second ingredient would be, you can write H plus, or some people write H plus H2O. Some people write H3O plus. Like you can do whatever you want for the exam. I would give everybody points. But the basic idea is we gotta neutralize the O negative ions. And that's how we're gonna prepare, all right? So let me delete this. Okay, so that's how we got it. Now question is, how would you go from here to here? So that's how the retrosynthesis, we are trying to go from here to here, but we're gonna design a multi-step synthesis. Can you do it? Yes, we can do it. All we have to do is oxidation reactions. And we know that secondary alcohol can only be oxidized to a ketone. So it doesn't matter what kind of reagent you're gonna use. You can use chromic acid, it'll still gonna form ketone. But if you had an aldehyde here, if you have a primary alcohol here, you cannot use chromic acid. So let's just default, by default, we will be using pyridinium chlorochromate with dichloromethane. That's gonna you could have used Swan oxidations, you could have used hypochlorous acid, or you could have used Desmartin poriodinin as well. So all of this would work. The basic idea is all we need to do is oxidize this into some sort of ketones. And there we go. That's how we did it. So let's try to do the next problem. All right. So how will we convert this one? So we had an alcohol. So how would we do this? So let's start here. So how would you prepare this one? The same way. if I had somehow a ketone here, and then I will treat this with phenyl. So this is a phenyl group, right? MgBr. And then this would come and attack here, right? So that's it. And then how can we convert this from here? Well, we have already done this, so we could use PCC and DCM. So this portion here is basically a phenyl group, right? So this is our phenyl group. So phenyl group, those who don't know, remember the benzene ring is, so it's alternate double bond, and everybody has a hydrogens, 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 hydrogen. So your benzene ring, one of the hydrogen is replaced, and when something is attached here, that's our phenyl group. In this case, what is attached here? We are attaching MgBr. Okay, so that's how the phenyl group is here. So one of the hydrogen is replaced by something else. That's when we call it, it's a phenyl group, just like methyl group. This is one hydrogen is replaced by something else. Okay, so this is MgBr. And there we go. That's how we make it. Okay, now we're going to learn another multi-step synthesis strategy in the next problem.